Okay, here's the explanation for the concept of the derivative. GetAFive questions. Number one is just recognizing which one correctly plugs this function into the limit definition. So when I'm glancing at these, first thing that I see is that answer choice 1 is out. None of our limit definitions include the limit as x approaches c. So that answer choice is out, and so is the fourth answer choice. So we're only really down between two, and maybe none of these, but usually one of these is right. So let's look at the second one. Remember that they're using the h's, so it's the limit as h approaches 0 of f of x plus h. So we plug x plus h into the function where we see x. That looks correct on the first one. It should be x plus h cubed minus 4 minus f of x, so then just plugging in the function, over h. They kind of mess up plugging in the x plus h in the third answer choice there. So it is indeed the second answer choice. Okay, so we'll keep going. Now, let me give you a little insight on the second one. If you didn't know what to do, it's okay. Because in order to algebraically manipulate this, you have to use the sum or the sum identity for tangent. Now, there's no point in you learning that, really. I don't see them actually testing you on that. But what they would be testing you on here is recognizing that the function is the tangent of 2x, and then recognizing that this is the limit definition of it. So once we get into derivatives a little bit more and we learn some derivative rules, you will learn that the derivative of tangent is secant squared, and then because of that 2x, it kind of throws things off too. So I'm just going to go ahead and tell you that this is the answer. 2 secant squared of 2x is the answer to this problem. Don't worry about not being able to answer that yet. By the AP exam, you'd be able to pick out that answer choice that quickly, okay? All right, and then question number 3, they're just asking us which of these is valid for the limit definition. So it wants f prime of a, the derivative at a point, okay, the derivative at a point. So the first one is an option for finding the derivative at a point. As x approaches a, f of x minus f of a over x minus a. Okay, the second one is also valid. F of a plus h, it's just replacing the x with the specific point a that we're asking about. So the second one works as well. The third one is the limit definition, okay, but that is just going to give us f prime of x. That gives us the general derivative for the entire function, not at that specific point. So this one is 1 and 2 only. Okay, and then let's just make sure that I haven't done anything silly. Let's check these. Okay, number 1 is correct. Number 2 is correct. And they kind of, well, yeah, they don't really show you that. They just kind of go through the explanation that that's the function, and so that's the derivative. I'll show you those rules later on, okay? And then, like I said, it gives f prime of x, not f prime of a. All right, so let's look at differentiability. Okay, here's our function. A and b are constants. If f is differentiable at 1, what's the value of a plus b? So if we can take the derivative, it's kind of like with our limits. The derivative on the left side has to be the same as the derivative on the right side. So on the left side, the derivative is 2ax. On the right side, the derivative is 1. Okay, so we're talking about at x equals 1. So 2 times a times 1 equals 1. So that means a is 1/2. Well, let's see here. We got to figure out what b is. So not only do the derivatives have to be equal on each side, then it has to be a continuous function. So we have to have the same y value when x is 1. So we know what a is now. We've got 1/2 times x is 1. And then for the right side, x is 1. We don't know what b is. So we've got 1/2 plus 1 is equal to 1 minus b. So those 1's cancel. and that means negative 1/2 is our b. So if we add a and b, 1/2 plus negative 1/2, we get 0. Now notice they have both 1/2 and negative 1/2 as answer choices. They're banking on somebody doing something silly, not paying attention, and just picking the first answer that they get, which is either 1/2 or negative 1/2. So make sure that, and they do that a lot, they will put a lot of intermediate answers as answer choices. So you got to make sure that you actually answer the entire question. Okay, let's look at number 2. We've got a piecewise function at x equals 3. The function is undefined. Well, let's see here. At 3, we can plug in 3. 2 times 3 is 6, minus 1 is 5, so that's not a problem. So then the rest of it is continuous and differentiable. So let's test continuity first. So when we plug in 3, 3 squared minus 4, that's 9 minus 4, which is 5. And I just said the other piece, 2 times 3 minus 1, 6 minus 1, that's 5. So our left side and our right side give us the same value, so it is continuous. Okay, continuity, we're good. Differentiability, let's take the derivative. We get 2x on the left side, and we get 2 on the right side. This is looking like it's going to be a problem. 2 times 3 is 6. 6 is not equal to 2. So it is continuous, but it is not differentiable at x equals 3. At other places, not a problem, but at x equals 3, it's continuous, but not differentiable. Okay, number 3. Let's see what we've got going here. Consider the function f shown in the graph. At which of the indicated points is f not differentiable? Okay, so at x equals b only. Well, yeah, it's definitely not differentiable at b because it's not continuous. Let's see here. Number 2 says at a and at b only. Okay, well, a we have a hole, so it's not continuous there. So if it's not continuous, it's not differentiable. So a and b, both of those are issues. So let's look at I know these are kind of scattered here. B and D only. Well, we said A is not differentiable, so it can't be that one. C and E only. Well, let's see here. C's no problem. C is completely continuous. It's differentiable. Not a problem. So that one's definitely not right. And then we've got A, B, and D. So let's double check. A, hole. B, jump discontinuity. D, sharp point. Not good. So it is not differentiable at A, B, and D. Okay, number 4. Similar thing. It says, which of the following statements are true? Number 1, f is continuous for all x between negative 4 and 6. Yeah, it's continuous. I don't see any issues. It is continuous. It's smooth. No holes, no jumps, no vertical asymptotes. We're good. F is differentiable for all x between negative 4 and 6. What about that point right there? That's not good. That's not differentiable. So statement number 2 is not good. Let's look at statement number 3. The limit as x approaches 0 of the function is negative 2. As x approaches 0, the limit is negative 2. That one's good. They're just kind of throwing you a soft pitch right there, honestly. That's pretty easy. So it is 1 and 3 only. Okay, it is 1 and 3 only. So let's check out and make sure. One is correct. And you can look at those explanations if you want. 2 is correct. And 3 is correct. And 4 is correct. Forgot there were 4 on this one. Okay.